Welcome to CEDA-Labz. Let's first answer the question asked in Module 2, Switch Level and UDP, tutorial. First was to design a Verilog code for 2-input NAND gate using switch level modeling. Here is the code for the same. Module is followed by module name and port list. Further, followed by ports declaration. Power and ground sources defined as supply 1 and supply 0. Internal connection W1 is defined as wire. PMOS and NMOS primitives are instantiated accordingly. And as usual, terminating the module via keyword end module. Another one was to design a Verilog code for 4:1 multiplexer using user-defined primitives concept. Here is the code for the same. As we already know, UDPs are defined with the keyword primitive. So, it starts with the keyword primitive, followed by primitive name, which is again followed by port list. Then, we declared the ports. Initiate the state table with the keyword table. First column represents I0, second one represents I1, third represents I2, fourth one represents I3, fifth and sixth one represents S1 and S0 respectively. And, columns separated by colons represents out. This table covers all the input conditions of a multiplexer using don't care conditions. Then, table is terminated via end table and primitive is terminated via end primitive. ModelSim is a verification and simulation tool for VHDL, Verilog, System Verilog, and mixed language designs. Luckily, there is a free, student version of ModelSim that can be downloaded from the following location: www.model.com/resources/student_edition/download.asp. Follow the instructions on the page to install the program and obtain a student license, which they will send to you via email. Once you have received the license and everything has been properly installed, ModelSim should execute without issue. Navigate to the Help PDF documentation pull-down menu and select Tutorial from the list. Thankfully, ModelSim has provided a simple explanation on the basic use of the application. Read through and follow along sections 1, 4 and 6 using Verilog. Note that ModelSim tutorial will not instruct you on the syntax/use of Verilog. Launch ModelSim. And, start by clicking on File, New, Project. Create Project window will pop up. Type the project name. And, you can also browse for new location, if you want to change. And then, click OK. As you will click OK, another window will pop up asking in case you want to add items to this project. If you want to create a new file, select Create New File. In case you want to add existing file, select Add Existing File. Select Create Simulation, in case you want to create simulation file. To create a new folder, select Create New Folder. Another window will pop up asking for the file's name and file type. After giving file name and file type, click on OK, then close the window. Add items to the project as we are not adding any other file. If we need to add an existing file, then we click on Add Existing File and browse its path. Alternatively, we can add file in the project via File, New, Source, Verilog. Now, right-click on and .v file in the Workspace tab and select Edit to write the code. Write the code for the same and save the file. Now, right-click on the and .v file again in the Workspace tab and select Compile, Compile selected. Alternatively, you can undock your file and then compile your code by selecting Compile from the options. In Transcript tab, successful compilation will be displayed with green color. Also, in Workspace, green tick against our file name will represent successful compilation. Now, we will add another file to the project for writing test bench, following the same instruction discussed before. Then, compile the test bench with the same procedure. Now, we will simulate our code to test its functionality. And how we will do it. Click on Simulate, Start Simulation. After clicking on Simulation, a window will pop up asking which file to simulate. Click on Work and select the test bench file. Then, click OK. This window will appear as we select the test bench file. In the Sim tab in the workspace, right-click on the instance, move your cursor to Add, then to Wave, then select all items in region. Then, the Wave window will appear. Click to undock the Wave window. Click this icon to run the simulation. As visibility is very low, click this icon to zoom full. This is clearer waveform after zooming. To terminate simulation, go back to the Simulate option and click on End Simulation. Another window will pop up to assure that you want to end the simulation. Click Yes if you are sure. Now we will do another example of a combinational circuit. Let us do it for decoder. So to add another file, we will right-click on the project window, then click Add to Project and then New File. A window will pop up asking for the name of this new window. Name this file, say, com_decoder. As we are studying Verilog, add file type as Verilog. And then click OK. To edit this file, right-click on com_decoder Verilog file in the project file and click on Edit. On the most right-hand side of this ModelSim window, there is this icon of undocking. Click to undock. This file will pop up in another window, then to compile, click on Tools and then on Compile. And again on the most right-hand corner of the window, there is an icon of docking a window. Click on it, dock the file back. And below in the transcript window, you will see if the compilation is successful or not. If not, then it will show you in which line and of what type error has occurred. We have done coding of decoder's design block, now we have to design its test bench. So, in order to write test bench, we have to add another file to this project. We will add another file via a different method this time. Click on File, then on New, then Source, and then Verilog. A blank Untitled tab will pop up. Write code for your test bench. And then click on this Save button or just press Ctrl+S. A window like this will pop up to name this file and browse its location. Let name of this file be tb_decoder. Do not forget to mention .v extension. If we make file via this method, then it will not be shown in the project window but will be saved in the project folder, and also when saving this file we necessarily need to mention .v extension, otherwise it will not consider it as Verilog file. After saving the file, what is our next step? Our next step is to compile the file. As this file will not be visible in the project window, we won't be able to compile this file with the previous method. So in order to compile the file, undock the file from the main ModelSim window via clicking on Undock icon on the right-hand side corner of this file. This file will pop up in another window. Click on Tools in the menu bar and then on Compile. To see the compilation result, we will have to come back to the main ModelSim window and see the result in the transcript window. If the compilation is successful, it will be shown like this. And in case of failure, errors are shown here. When both the files, design file and test bench file, are saved and compiled, we simulate the design. So, to simulate the design, click on Simulate in the menu bar and then on Start Simulation. A window will pop up to select the file which needs to be simulated. Undock the work library and select the test bench file which is to be simulated. Here it is tb_decoder_com. But did you notice that we named the file as tb_decoder, but in this list it is tb_decoder_com. In the last slide, if you had noticed, this name is test bench's module name because in library, file is saved by its module name. So after selecting this file, click OK. As soon as you click OK, design will start to upload, and you will see stacked windows like this. In Workspace window, right-click on the tb_decoder_com file, then click on Add, then to Wave, and then All items in region. Due to our last step, a waveform window will pop up. Undock that waveform window in order to see the waveform result. As we already know what to do next. Do you remember? First we will click on Run. A waveform will be visible but it is not clear as it is stacked up. So next is to click Zoom Full icon so that waveform is visible clearly. Analyze the waveform and check if it is correct. And dock it back to go back to main ModelSim window or just click on Cross to close the window. If it is incorrect, you should check your design block code and test bench code in order to find the fault. And in case it is correct you should end the simulation. For that click on Simulate and then on End Simulation. A window will pop up to assure that you want to quit simulation. Click Yes if you are sure. Let's do another example, but this time of a sequential circuit, flip-flop. Now I hope you can add file via any method. Let's add it via older method. So how we will do it? Right-click on the project window, and then on Add to Project, then New File. In case you want to add any existing file, you may click on Existing File. A window will pop up for file name and its location. Let name be, say JK_FF, because we are designing JK flip-flop. And file type is Verilog obviously. Click OK. Now you can see the file in the workspace window with a question mark, which means it is neither edited nor compiled. Right-click on it and select Edit. So here is the design code for the JK flip-flop with active low asynchronous reset and active low synchronous preset. Click on Dock icon to undock the file in order to compile it. Click on Tools, then on Compile. Click the Dock icon to dock back the file in the main ModelSim window and see the compilation result. And as you already know, in the transcript window you will see the compilation result. We have completed with design code. Now we will add another file in order to write test bench module. And how we will add it? File, New, Source, Verilog. Write the test bench code and then save it. And then undock it in order to compile it. Now you tell what we do next. Remember? We will compile the file. How? Click on Tools and then Compile. Do not forget to dock back the file. In transcript window, see the result of compilation. Now we are done with the designing of both design code and test bench code. What we will do next? We will simulate the design. And for that we will click on Simulate and then Start Simulation. Another window pops up in order to select which design is to be simulated. Select the file and click OK. You remember now that your file is displayed with module's name. As soon as you click OK, design starts uploading and you see these windows side by side. In the workspace window, right-click on the file and then on Add, then to Wave, then All Items in Region. A waveform is added. Undock this waveform window. What next? Click on Run icon and then on Zoom Full icon. And here is our clear waveform. To end the simulation, click on Simulate, and then End Simulation. Another window pops up to assure your decision. Click Yes to end the simulation. If you want to close the ModelSim window, click on the red cross button on the rightmost corner of the window. Another window will pop up to assure that you want to quit. Click Yes if you want to quit. Try doing some Verilog codes on your own at your end. Thank you.